In the last video, we talked about endpoint availability, whether an endpoint can actually serve traffic when it is needed. Today, we are stepping one layer deeper to something even more fundamental: endpoint reachability. Endpoint reachability describes whether a network can successfully deliver traffic to an endpoint and receive a response. In simple terms, it answers a basic question: can the network reach this endpoint at all? A useful metaphor here is a road system. Availability is whether a shop is open and able to serve customers. Reachability is whether there is a working road that leads to the shop. A shop can be perfectly stocked and fully staffed, but if the road is blocked, it might as well not exist. Endpoints behave the same way. If traffic cannot reach an endpoint, everything else about that endpoint becomes irrelevant. At the most basic level, reachability starts with addressing. The network must know where the endpoint is. This usually means an IP address, but more generally, it means that the endpoint has some form of network identity that can be routed to. If an endpoint has no valid address, it is unreachable by definition. Next comes routing. Even if an endpoint has a valid address, the network must have a path to it. Routers must know how to forward packets toward that address. If no route exists, packets are dropped, and the endpoint is unreachable. From the network's point of view, unreachable endpoints simply do not exist. Reachability also depends on network boundaries. Firewalls, access control lists, and security policies can intentionally block traffic. In this case, the endpoint may be physically present and technically functional, but logically unreachable. This is an important distinction. Unreachability does not always mean failure. Sometimes it is the result of deliberate design. Private endpoints are unreachable from public networks by choice. Internal systems may be unreachable from the outside world, even though they are fully reachable internally. Endpoint reachability is always relative to perspective. An endpoint may be reachable from one network segment and unreachable from another. This is why reachability tests must always ask, reachable from where? Another key aspect of reachability is protocol. An endpoint might be reachable using one protocol, but unreachable using another. For example, an endpoint may respond to basic network probes, but block application-level traffic. From a networking standpoint, reachability is layered. Lower-layer reachability does not guarantee higher-layer reachability. Being able to reach an endpoint at the network layer does not mean you can successfully communicate with its services. Reachability is also time-dependent. Networks are not static. Routes change, links fail, policies update. An endpoint that is reachable now may become unreachable moments later. This is why reachability is continuously evaluated rather than assumed. Monitoring systems send probes. Routing protocols exchange updates. Networks constantly adjust their understanding of what can be reached. Reachability also interacts closely with endpoint state. If an endpoint goes offline, its reachability disappears. If it comes back online, reachability must be rediscovered. In dynamic environments, such as cloud networks, endpoints may appear and disappear frequently. Reachability must be established quickly and removed just as quickly. From a behavior perspective, reachability is the foundation of all higher-level network decisions. Traffic can only be sent to endpoints that are believed to be reachable. Load balancers remove unreachable endpoints from rotation. Routing systems avoid paths that lead to unreachable destinations. If reachability information is wrong or outdated, network behavior becomes unstable. Traffic is sent into black holes. Connections hang. Retries multiply. This is why accurate reachability detection is critical for performance and reliability. Reachability is also central to troubleshooting. When something fails on a network, one of the first questions is always, is the endpoint reachable? If it is not, there is no point debugging application logic or performance. You must restore the path before anything else matters. In security contexts, reachability defines exposure. An endpoint that is reachable can be interacted with. An endpoint that is unreachable is effectively isolated. This is why reducing unnecessary reachability is a common security strategy. You do not secure what cannot be reached. In modern distributed systems, reachability becomes more abstract. Endpoints are often reached through intermediaries such as gateways, proxies, or service meshes. The endpoint itself may never be directly reachable by clients. Instead, reachability is mediated and controlled. This allows networks to change topology, scale endpoints, and enforce policy without breaking communication. The core idea remains the same. Reachability is about whether traffic can get from one point to another. Without reachability, there is no communication. Without communication, there is no network behavior to speak of. Endpoint reachability is the most basic promise a network makes. If that promise is broken, everything built on top of it collapses. That is endpoint reachability.